Hi my friends, today I model this sheet metal part which has some flanges, 1, 2, 3, 4, and the connection of them are this one, another flange, and this one, another flange. This was needed for using this hole to place it on a wall. You see better the situation here, where this is the real part cut it by a laser, and my mission was to create the model, to create the flat pattern, and then transferring data to AutoCAD for the company with the laser, as I told you in the intro. The drawing of this part is this one, and we'll use carefully all the dimensions here. The first couple of dimensions is 468, 285 for the face, the upper face, this face, which must be created firstly. Let's do this. We start by creating a new part. Which kind? Sheet metal. Firstly, we place the thickness. If you take a look here, you see thickness is 2 millimeters, thickness is 2. We have dimensions in the drawing. Okay, then sheet metal defaults. I don't use the rule, I use my special dimension. Okay, the plane for the first sketch is this one, but with the X to the right. Then I create a drawing consisting in a rectangle. Dimensions 4, 6, 8, tab 285. Enter. Home. You see the rectangle. Finish sketch. And now face. Face is corresponding with extrusion, but the dimension, the height is 2 millimeters. Let's apply. OK. And you see the first volume. The material is stainless steel, as you saw in the picture with the final part. Good. This is the first volume. Okay. We continue with this flange, which is dimensioned here. 4 millimeters is the offset and 440 millimeters is the width. The distance or the height is 34 from up to bottom end. We do this very easy because we know the procedure. Flange, this is the edge. 34 is the dimension. We extend the dialog box. We select width. We select offset. The measuring starts from the left here, but the other direction. 4 millimeters and 440 millimeters. Okay. You see the same situation with this face aligned with this tiny end of the first face. Now we have here the best situation to create the next folding. So we do this, but let's see what is the dimension. The dimension is missing. Let me apply a new dimension to the drawing. The drawings are made by me and I am human. I have my right to make mistakes at my age, my friends. 30 is this value. I don't see that dimension anywhere in the drawing. So let's create the flange from here with the value of 30, and we don't need to extend anything because we don't have an offset, we don't have another length or width, but the same with the previous flange. Okay, if you measure by using M from Monaco, if you measure the distance here, you see that it really is 30 millimeters, and also this dimension is 34, you see here. Okay, we go further with this feature, corner round. What is its dimension? We see that dimension here, radius 10. No problem, we go here, we apply corner round, we select the edge, we apply our dimension 10, and okay, now you have that corner round with which seems to be this tool fillet. Yes, this is a fillet, but in the sheet metal environment it is named corner round. Good. Next is this flange, which has two dimensions, left and right, two offsets. We can take a look to the drawing. The left is 4 millimeters, but it becomes the right from the end, and the other is 14. The total distance is 100. Remember 4 and 15. We turn the part, 15 is to the left, 4 is to the right. We apply flange. We place the value of 100. We select the edge, but clicking here. This must be the first action. Then we extend this, and instead of using width, we use offset. Offset 1 is from here, my friend. You see, it seems to be here. No, this is the end. And the other offset, which has the value of 4 millimeters as before. The other is this end with 14 millimeters. Okay, very nice. Next is this flange with dimensions here. You see, 30 millimeters is from up. No, we don't use now this dimension. We use only 100. And we also use this distance, my friends, 24 millimeters. Yes. The other end is the end of the part. So we use again that extension, flange, the bottom edge, 100 is the same, edge is now offset, and measuring from the left, the value is 24, and measuring from the right, the distance is not 14 but 0. Yes? Okay. Now we create the cut here with that 30 millimeters from this view. Yes, 30 millimeters is all it remains from 100 at the other end. Good. We have to create a cut now. This is the face. We draw a line starting from here, ending somewhere, and we place the dimension from this end point to the upper face, which must be 30. Finish sketch and cut. What to cut? This? No, no, no. This. What is the depth of the cut? The thickness. We don't cut also this flange, only the thickness of this and the right. Okay. Again, we have here a corner round, which is dimensioned right here, radius 10. Good. Radius 10. We apply corner round and the value of 10. Okay. We continue with this flange. You see, the bend edge is vertical now, which has dimensions here. 100 is this, and 100 8.9 is the distance. Let's do this. We go here, we apply flange, we select this edge, and we place the value of 108.9. The result is this. Yes? Why I have here such a precise value? This value creates a gap here of 0.1 millimeters. You see, if you place here the 109 distance, you have no gap, and this means that you cannot unfold this part. Let's see. Create flat pattern. The flat pattern has some parts, some faces or flanges not flatted. Oh, go to folded part. We apply again 108.9. We see the gap, yes, and now we can apply go to flat pattern, and we have the flat pattern as in the drawing, this one. Okay, we go back to folded part and we make some cuts at these two corners. The cuts are dimensioned here, radius 7 and radius 17, but they will result. You see, I select this face to create a new sketch. The sketch is an arc from this point to this point with a certain radius. I see here tangent. I place also tangent between this arc and the certain line here, and we have also tangent. If we place a dimension, we see that the result is 17. Yes, I don't apply this dimension because, you see, we must create it as a driven dimension, and I don't need to create a driven dimension here. The same for this other corner, starting from here, ending here, and with at least one tangency. You see, now I have both tangents because the radius is 7. You see, everything is obvious. Good. Finish sketch and cut. We apply cut to this I have to select precisely this corner and also the other one, which is right here. this one. Yes, the depth of the cut is thickness. Now we have the result. Good. Next is the multiple cuts on this face. We have here all the dimensions. You see there is a rectangle here which limits the length of the cuts. Distance are 54 on all the four edges or margins. Let's create the rectangle. Then we use slot as a tool, not rectangle. The radius is 2.5. This means that the diameter is 5. And the other dimensions. Let's do this. We select this face, sketch, but let me apply construction, and to place construction as default to create that rectangle. Then I disable construction because I'll apply real useful cuts or lines. 54, the same is here, so I select the same value. Okay, D78, I'll use it all over. D78 from here to here. D78, which is 54, 54, excuse me. Again, D78. And now we have the limits. I go to rectangle, I select slot center to center, and I draw a first slot. Its dimension is twice 2.5, because the dimension is 2.5 in the drawing. You saw this. Then the angle from the middle to this line of 45. Tangencies. This arc is tangent with this line. The same arc is tangent with the left line, and the other arc is tangent to this. Good. Now, if we take a look here, we see the same value for 4 times. This means that we have 5 cuts parallel, identical with the first one, which is this placed in the corner. Yes? Oh, let's use the pattern, the rectangular pattern, by selecting this all space, but I keep shift pressed now to select this which must not be included in this pattern apply. I select the first direction, this is the first. I don't use another direction. The number of cuts is 5, and the distance, as you saw, is 45.4. Okay, now we have 5 cuts. This is not right and the point. The dimension for 45.4 was created by me, making a small calculus here, and nothing is important here to apply an exact value, you see. The next cut is this one. Now I cannot place a dimension distinct, so I apply equal for this arc with another one. The parallel of the two, and the distance of 31 for the first. 31. You see here 31. No matter if we use sides instead of centers. I don't place here centers and other details. They are not necessary. Then I apply tangent for this arc and this line, and the other is here 31. The other are 30, 30, and here also 30, all of them. And tangency and the same 45 degrees, so we can work very easy now. Another one is this one, equal between this and this, parallel any side with this, dimension of 30, tangencies at the ends, another slot which has an equal radius here, the same parallel lines, the distance of same 30, so I select it from here, and tangencies at the ends. This is one, this is another one. We draw here other 3 slots, 1, 2, 3. This is parallel with the previous one, so I'm happy. This must be equal with this, and the other two same. Parallel is this line with this line, this line with this line, and these are already parallel, as I suppose. Yes, cancel. Distances. The distance between centers or sides, but respectively sides, and I select the same value, D92. Yes, tangent now, here and here. Distance between these two is D92. Yes, D92. Remember D92. This is here and this is at the other end. Dimension D92. Tangencies, and this is all, my friends, with the cuts. Finish sketch. Cut. We select each slot. Okay, 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 and okay. Now, as you can see, we have finished these cuts. And now the holes. There are two holes here, 50, 170 with a distance of 40 and diameters of 6. We go to this face, we select the sketch, I apply F5 to have the same view, I place 2 point, 1, 2, I ask for being on the same horizontal, I place the dimension of 40, the dimension of 50, which is here, and 170. Finish sketch. Hole, diameter of 6, not 5. Okay. Then we work with this face, this double face. Dimensions are here 109, 150, 150. The distance is also 40. And the diameter is also 6. Okay. Sketch. F5. 3 points. 1, 2, 3 is here. The same horizontal for all 3. The distance of 40, the distance of 90, not 90, 150, 150, I must move this to the right because this distance, not this, but the projection of this, you see the projection here? Yes, to here must be 109. Finish sketch. 3 holes, of 6. Okay. And on this face another 3 holes of 5 millimeters with a distance of 10, with a distance of 30, and this distance is between them, 90, 150. 80. To do this, we start by applying sketch, drawing a line with a length of 180 as in the drawing, which must be parallel with the edge, a distance of 30 from the left, and 3 points. 1, 2, 3. The distance between the first two is 90. The other distance is already placed, 180. I prefer to be so. And one dimension needed, 10 millimeters between these two lines. Hole 4, not 4, 5. Okay. F6, and that's our part. My friends, this is all. Let's see what is the volume. The volume is here. You know very well this. Copy, close, drawing, home, double click, and we place the new value here, which is identical, my friends. Absolutely identical. This means that we worked very well. Now we have the 3D model and we want to send the data to the laser cutting company, but they use AutoCAD, not Inventor. We must be sure that this object can be flatted, so we try to obtain the flat pattern. We have this flat pattern, we verified it's okay. The first solution to send data to AutoCAD is to create a drawing as a DWG drawing. Double click, and this is what we have, usually A3. Let's see what is its dimension. A3 landscape. This is the presentation of the drawing. We don't need the border and table, so we delete them. Then we create a base, but not for the folded part, but the flat pattern. We select here the flat pattern, and we have the flat pattern as a drawing. We can rotate it to be in another position, and we select 1 to 1, not other scale. What? 1 to 1, because they use this drawing to cut the real part. Oh, but it is our part is larger than the page. How larger is? We want to create two dimensions. This is one and this is the other. We can read this, but it is difficult. So let's change the settings for dimensions. I make this view and I go to Style and Standard Editor. From here or from Tools, not Tools, Manage, Styles, Standard and Style and Standard Editor. We activate this or this and we use the default ISO template. So we have to change this template to increase the dimension of text. We go to text and we apply, say, 10 millimeters height of this dimension. Click somewhere and save. You see, we have another presentation here. We go back to default ISO display and we apply here also 10, 3, and save. We have other dimensions of the arrows and so on. Good. Now we modify the yellow page to have more than these dimensions. So we select custom size, height more than 447, say 600, and here $750. Okay. Now we move the drawing inside this page. Home. And we can modify positions. We have all the possibilities. We can create sketches to be added here, anything you want. We save the drawing. Under the name laser, and then we go to AutoCAD and we try to open that drawing. You see, we have here a message. This drawing is read-only. Would you like to open the file read-only? Yes, I want. We have the drawing, but you if you are familiar with AutoCAD, you see here a triangle, and this means that you are in paper space instead of model space. In a word, this is not a proper document for the laser cutting company. We need to find another solution for this problem. So I don't open, I don't use. What to do? We go back to this DWG drawing and we export it as a DWG drawing. You can say, well, this is already DWG. Yes, it is. But now we use export to DWG to have a real AutoCAD document and not a document created in Inventor. You see, this could be an IDW, not DWG. And then export to DWG sounds very well. I use this kind of procedure, and you see we can apply some options. AutoCAD 2018, 2013, because we don't know what AutoCAD license has the laser cutting company. Next, some other options. We don't change any of that options, and we go to finish. Finish under the name laser genuine. DWG. Save. Now, if we use AutoCAD to open this genuine DWG, we don't have a message of read-only, and we are in model space, not paper space. We can add anything we want here. For instance, we introduce not this one, but this one, single line, with direction and height, and we write here the material, stainless steel, and so on. You see, it is not beautiful, not useful to add here any dimensions. So we go back. I don't save this. We go back to Inventor, where we are familiar, and we write here all we want. These dimensions are useful for the laser cutting company. I apply text to write here a name, shelf, and material, stainless steel, thickness 2 millimeters. You can write anything you want there, and the company will cut the contour, the holes, cuts, everything by using the data and having the general dimensions here. Now I can export this final drawing as a DWG, finish, directly finish, under the previous name, yes. Then we go to AutoCAD and we open that new DWG with our text, and from AutoCAD you can save also as DXF. Yes, you select here DXF 2018 or other year in order to be compatible with the license of the laser cutting company. Well, that's all for today. Thanks for watching. Bye bye.